Hello everybody, this is Cameron Snow with Danomics.com. In this video, we're going to be expanding on what we've already done in our Danomics Basic series, and we're now going to take on wellbore stability. So let's get started. By this point in your analysis, you should have already gone through, done your log QC work, calculated all your key reservoir properties, and then you will have also needed to have done your pore pressure determination, as well as doing the work on the shear log modeling and the geomechanics to make sure that we have all the prerequisites for calculating our wellbore stability. Now in this video, we're going to be focused on a vertical well. However, I do want to point out that within Danomics, we have the ability to bring in deviation surveys, and this calculation can be performed on the arbitrarily oriented wellbore in 3 dimensions. If you have a highly deviated wellbore, and you're drilling, against the stress direction, perhaps, you can go through and use that information. So let's dive in here and take a look at some of the aspects of our wellbore stability model. So first of all, we have some of the things that we worked on in our pore pressure module. So we have, our pore pressure here. So we can see where we have some overpressure calculated down here in some of these deeper formations, as well as a couple of spots here up shallow. We can see our caliper response here. So we have our caliper mirrored here. So we can see where we have some significant washouts in the section. Remember, those washouts may be caused by wellbore instability. So that's important to take into consideration. We have our geomechanics plotted here in the middle track, as well as our shear logs. So, once again, this comes from our shear log modeling work. This is a well that didn't have a measured shear, so we had to use a synthetic. And then that synthetic was used to calculate our geomechanical properties. So you can see where a lot of our interpretation is starting to get pulled together here into some of these later modules. Now we're going to zoom in and focus on the section here where we've got better log coverage. And we'll talk about some of the options that we need to take into account. So first of all, when we normally think about our Young's modulus, we're thinking about the dynamic Young's modulus. We need to do a conversion over to static Young's modulus, and there are a number of correlations that are available for this, and these all work over different pressure ranges. So I'm going to use the Christiaris et al. Method. This covers a pretty wide range of pressures. We also have ISA and Kazi, Lacey, which is quite a good module for handling some of the lower pressures, as well as some of the more classical ones, such as King's model and Noor and Wang. We have several of those built in for you. Remember, you can always add your own. For unconfined compressive strength, we need to choose an appropriate model here. I'm particularly fond of Lev Vernix models if you're working with sandstone reservoirs. If you're working with limestones and dolomites, the Golubev and Rabinovich models are ones you'll probably want to take a look at. Or there are a number of methods that are specific to local areas, especially if you're working in like the North Sea or the Gulf of Mexico. There's been a lot of work in those areas. I'm going to use this Freiberg sandstone model here. You'll need to determine your internal friction angle. We've got 3 methods in here for that. We've got Law's 1999 model. We also have Weingartner and Perkins, their 1995 models for sandstone and mixed systems. Depending on the methods you select, you may also have to put in some additional parameters here. But with the ones that we're focusing on right now, the parameter that we really need to focus on is our tensile strength. So when we look at our tensile strength in the rocks, if we have a higher tensile strength, that's going to make it less likely that we have tensile failure in our system here. And you'll notice that gives us a wider mud weight window. And as we move to lower tensile strengths, we can see that our upper mud weight window will come down. And the last thing we need to consider are how do we want to think about our min and max horizontal stresses. So we've got a few different methods that we can use here, such as Eaton's methods, Eaton with Biot, Holbrook, Hubbard and Willis. Um, so that's for our minimum horizontal stress. For our maximum horizontal stress, less options to choose from here. We have Otis's normal and strike slip faulting methods, and we also have Eaton's method with the Biot coefficient. That's what we're going to choose in this case. And this actually gives us a couple of extra parameters that we need to evaluate here. So, you know, it gives us a tectonic stress direction that we need to set. It also gives us a maximum stress here. So this is the tectonic stress that we need to set um, that we'll use for that maximum horizontal stress calculation. I want to show you how these will affect things. Now, in this case, we're working with a vertical well, so our tectonic stress direction doesn't matter for the calculation of our mud weight windows here. It will, however, matter if you are working on a deviated well bore, so just keep that in mind. Now, if you were to set a very low maximum horizontal stress, what you'll see is that we have wider mud weight windows, and as you increase that, those mud weight windows will start to narrow. So you know, we'll be more likely to have tensile failure there. All right, so let's let's assume that we have looked up the correct measurements here for our regional tectonic stresses. We've got our tectonic stress direction correctly if it's a deviated wellbore, and let's take a look at some areas where we have some known drilling problems in the area, specifically down here in the Mowry and Muddy formations. These are areas where we often see significant washout, um, very challenging drilling conditions here, and and sure enough, what we see in reality is we generally have quite easy drilling conditions through the shallow part of the section here, and this makes sense because we have some very wide mud weight windows. So we're able to come through here, essentially drilling with normal mud weights, maybe slightly elevated mud weights here. But then we get down into this older section. We start to get into the Mowry and the Muddy, and we start to see that we have narrower mud weight windows that are available to us, and this is based on a combination of the geomechanics and the pore pressure and our tectonic stresses. And we can see that in some areas, you're just not going to be able to effectively drill this without getting some type of either more Coulomb or tensile failure in your system based on your mud weight windows. And that's exactly what we see in reality here, where you either have to, you really have to mud up coming through this system, or you have to deal with failures on the other side. So you're really trying to thread the needle in this area, and if you make the mistake of mudding up too much, then once you get into the Dakota, you're gonna flip over and start to have failures on the other side of the mud weight window. So it can be quite a challenging drilling environment here. Um, so once again, this is one of the more advanced modules. It requires you to have already gone through and calculated, all your key reservoir properties, calculate your synthetic shear, calculate your geomechanics, calculate your pore pressure, and then we bring that into our tectonic stress regime, and we calculate those mud weight windows. And this is something, of course, you'll want to work with your drillers on when you're designing future wells. So when this is a well that was already drilled, we're doing a look back here, but we want to take this information over to our drillers and talk about it when we are planning our new wells, so that way they can be more effective and more prepared for some of the challenges that they're going to see during our drilling operations. All right, I hope this video was useful. If you'd like to learn more about how you can do this type of work in Danomics, feel free to shoot us an email at sales@danomics.com. Thank you.